Welcome to Night Lesson. Relax and learn along the way.
Intro: A silent giant. I recently conducted a small survey among those I know. I asked 18 people, who is Linus Torvalds? Only one knew, without Googling, and that is despite the fact that this man's work likely runs on every smartphone, every server, and in almost every aircraft that carries us safely through the sky. A silent giant. Almost no one knows him, and yet his work is everywhere. Imagine a cold autumn night in Helsinki. In a small, nondescript student room, a young man sits before his computer. The gentle hum of the machine and the quiet clatter of the keys are the only sounds breaking the silence. Line by line, he types code, not driven by greed for wealth or the fame of changing the world. No, his motivation is much more modest, deeply personal. He simply wants to create something better for himself, a system that meets his own needs. In these quiet hours, a modest curiosity lays the foundation for a silent revolution. Today, this revolution significantly shapes the digital world as we know it. Billions of devices, from the smartphones we hold in our hands to the most powerful supercomputers performing complex calculations, to the countless servers that keep the entire internet running, are permeated by this one idea that began that night. It is a fascinating story of how an idea, born of personal frustration and a deep desire for improvement, rose quietly and unstoppably against the established software giants of its time. It is the narrative of an individual who, in his wildest dreams, never imagined that his little hobby project would one day lay the foundation for one of the most consequential ideas in the history of computing. The principle of open source. We look back to a time when software was often a locked secret, expensive, opaque, and reserved exclusively for large corporations. The Unix operating system was considered a model for stability and performance, yet its availability was limited and its license expensive. In this vacuum, the thought germinated to build something of one's own, something free and open. A quiet journey awaits us, a journey through the creation of a digital giant, the silent power of community, and the profound philosophy of sharing that Linus Torvalds helped shape. Let us dive together into this captivating story of Linus Torvalds and the Linux operating system, a story that quietly but unstoppably changed the world and continues to inspire us today. Chapter 1: The Early Years in Helsinki, Birth of a Nerd, the icy clarity of Nordic winters, and the long, silent summer days shaped a childhood in Helsinki during the 1970s and 80s. Here, in this often contemplative environment, grew a boy named Linus Benedict Torvalds. His home was a place where books and intellectual exchange were a natural part of daily life, as his family was deeply rooted in academic circles. A very special influence on young Linus was his grandfather, Professor Leo Tornquist, a renowned professor of statistics at the University of Helsinki. This man, with his sharp mind and his ability to make complex ideas understandable, awakened in Linus an early fascination for logic and precise thinking, qualities that would later form the core of his genius. One day, at the tender age of 11, a whole new world opened up to Linus. He gained access to a Commodore VIC-20. This home computer was a modest device at the time, equipped with only 5 kilobytes of RAM, a tiny amount compared to the gigabytes we know today. But for Linus, this nondescript box with its clunky keyboard and black and green screen was not just a device, but a gateway to infinite possibilities. It was his first digital playground. Initially, he may have played games on it, but very quickly he realized that the true pleasure lay not in consumption, but in creation. Like a magician building his own props, Linus began to decipher the secrets of the device to bring his own programs to life. Curiosity was his constant companion, driving him to dive deeper into the inner workings of the machine. Without formal guidance or textbooks beyond pure basic knowledge, Linus began to teach himself programming. He started with BASIC, an interpretable high-level language that allowed him to see results relatively quickly. But soon he encountered the limits of this language. He felt that BASIC did not offer him the complete control he craved. So he took the step toward assembly language, a so-called low-level programming language that allowed much more direct communication with the computer's microprocessor. Here he could direct commands almost directly to the hardware. making individual bits and bytes dance according to his will. It was tedious but immensely satisfying work that allowed him to understand the computer's architecture from the ground up. The deeper Linus immersed himself in this digital world, the clearer his frustration with the limits of the systems available at the time became. The home computers of that era, such as the aforementioned Commodore, VIC-20 or later the more sophisticated Sinclair QL, were revolutionary for their time but also extremely restrictive. Their operating systems were monolithic entities, often proprietary and hardly customizable. They dictated what a user could and could not do. Linus began to dream of a system that not only reflected his own ideas, but also offered the freedom to shape and change it as he pleased. This vision, born of childhood curiosity and a growing dissatisfaction with the status quo, laid the foundation for a journey that would permanently shape the digital age. The isolation and intense concentration of his hobby became the breeding ground for his profound technical skills, driven by an irrepressible desire for ultimate control over the machine. Chapter 2: The Seeds of the Kernel. Minix and the Dream of Something of One's Own. With the transition from the sheltered world of his parents' home to the academic environment of the University of Helsinki, a new chapter opened for Linus. It was a time of intense learning and intellectual discovery, during which he buried himself completely in the subject of computer science. The lecture halls and libraries of the university became a breeding ground for his already alert mind. Surrounded by like-minded people who shared the same fascination for the complex logic and elegant structures of the digital world, his understanding of the core principles underlying every functioning computer system was formed and sharpened. It was not just the mere acquisition of knowledge, but a deep immersion into the way of thinking that forms the heart of modern technology. In the midst of this academic environment, where the study of operating systems played a central role, Linus came into contact with Minix. Minix was more than just another teaching system. It was a revelation. Developed by the renowned Dutch professor Andrew S. Tannenbaum, this compact, Unix-like operating system served primarily for educational purposes and was intended to introduce students to the internal mechanisms of a kernel without confronting them with the overwhelming complexity of a commercial system. Linus was fascinated by the clarity and elegance of Minix, which reduced the powerful principles of Unix to their essentials. The concept of the Unix philosophy, the idea that everything is a file, and the emphasis on small specialized tools that work together seamlessly and interact via inter-process communication, resonated deeply with Linus. It was a design paradigm that focused on simplicity and modularity, qualities that appealed to Linus intuitively. But as inspiring as Minix was, there were also limits that increasingly frustrated Linus. Although it was open source and allowed access to its source code, Minix was limited in its nature as a teaching system. Tannenbaum's licensing policy and architectural decisions, particularly the focus on a microkernel, which was elegant, but in his eyes, not optimal for performance, did not allow Linus to modify and adapt the system to the extent he desired. He felt a deep desire for more control, for the freedom not just to understand an operating system, but to shape and improve it according to his own ideas. This inherent need for adaptability became a central driver for the development of what was to come later. From this growing frustration and the deep-seated need to own a system he could fully control and adapt to his specific requirements, a new idea germinated within Linus, a vision that initially appeared modest and inconspicuous, but had the potential to change the digital world from the ground up. He decided to write his own small kernel. At first, it was no more than a hobby project, a kind of learning exercise for himself, to experience the concepts of process scheduling, memory management, and interrupt handling firsthand. He wanted to understand how these fundamental operating system basics worked in practice, not just in theory, in contrast to Minix's microkernel architecture, where most services ran in user space. Linus's early design tended toward a monolithic kernel from the start. He recognized the potential performance advantages of having all core services reside directly in kernel space, a pragmatic approach aimed at efficiency. This modest start, described by Linus himself as a mere leisure activity, gave no hint at the time of the scale it would one day assume. The seeds of this hobby project, nourished by Linus's irrepressible urge for technical control and the inspiration he drew from Minix, were to grow far beyond the boundaries of his study and set an entire movement in motion. It was the beginning of a journey that would show that something extraordinary can arise from the personal passion of an individual, something that reaches far beyond original expectations. Chapter 3: The Birth of Linux, the Miracle of 1991. Out of the silence of concentration that surrounded Linus Torvalds in his small study, a vision began to solidify that would soon change the world of technology. After weeks and months of tireless work on the heart of his new system, that central control point that orchestrated all operations of a computer, the kernel took on increasingly clear shapes. Linus sank deep into the logical structures responsible for memory management, that complex art of efficiently dividing the scarce and valuable RAM among running programs to prevent chaos and ensure smooth processes. Parallel to this, he dedicated himself to process scheduling, another fundamental task of the kernel that determined which application could use processor resources, when and for how long. It was a dance of efficiency aimed at giving each program its fair time on the stage of calculation without bottlenecks or standstills. Linus focused on the pure functional pillars, the abstraction of hardware, meaning the ability of the kernel to make the physical components of the computer accessible to applications while simultaneously protecting them. A graphical user interface was still a distant dream at this point, almost an unnecessary distraction from the elegance of the underlying architecture. His work was focused on laying a solid foundation that would master the principles of inter-process communication, the ability of different programs to speak to each other and exchange data in a safe and orderly manner. It was during this phase of intense development that a modest milestone was reached, the true scope of which was hardly foreseeable at the time. In the late summer of 1991, exactly on August 25th, Linus Torvalds shaped those lines that would soon enter the annals of computer history. He sent an email to the Minix newsgroup, a kind of digital bulletin board for like-minded people who dealt with the Minix operating system. His message was both inconspicuous and profound. In it he announced a new kernel he had written, not as a comprehensive commercial product, but as a personal project born of curiosity and the desire for more control. The famous words he chose echo to this day, and are often quoted with a smile. Just a hobby, won't be big and professional like new. These lines reflected the modesty of the time and the creator's lack of knowledge regarding the revolutionary potential slumbering in his young lines of code. He had created a system designed from the ground up to be Unix compatible, to facilitate the porting of existing Unix software, and thus build a bridge to an established software world that followed POSIX standards, a set of norms intended to ensure consistency between different Unix variants. The name of this emerging system itself was anything but a conscious marketing decision, but rather the result of chance and a friendly intervention. Originally, Linus had wanted to call his work Freaks, a creative word creation combining free, freak, and Unix, an expression of his appreciation for freedom, his own curiosity, and deep roots in the Unix philosophy. But fate had other plans. When his friend Ari Lemke, a system administrator at the Helsinki University of Technology, made Linus's early kernel available for download on a university FTP server, he made a spontaneous decision. An FTP server, at that time one of the primary methods for file transfer in the still young Internet, was the digital gateway to the world for developers and enthusiasts. Ari found the name Freaks not very memorable and replaced it with Linux, a simple but ingenious combination of Linus's first name and the familiar Unix. Without knowing it, Ari Lemke had created a name that would soon become synonymous with the open source movement and a new era of software development. It was a name that perfectly captured the collective creativity and spirit of collaboration, even though it had arisen so randomly. The impact of this inconspicuous publication was astonishing. In September 1991, only 1 month after the legendary email, the first official version of the Linux kernel, version 0.02, saw the light of day. These early lines of code were not perfect, but they were a promise, a testament to the power of pure functionality. Thanks to the young but rapidly growing Internet and the inherent openness of the entire project, news of this new, freely available kernel spread like wildfire in the digital communities. Developers around the globe, fascinated by the idea of a free, customizable, Unix-like system, began to download the code from FTP servers and test it on their own machines. It was an early form of crowdsourcing long before the term even existed. Everyone who participated became a potential co-creator, a gear in an emerging global clockwork of innovation. The possibility of direct participation, the lack of commercial barriers, and the open communication between Linus and the first testers were crucial for the initial success. From a modest hobby project, almost unnoticed by the general public, a community grew that was ready to redefine the boundaries of the possible and lay the foundation for a digital revolution whose echo we still hear today. Chapter 4: The Community Grows. The power of collaboration. From the modest seed of a university room in Helsinki, something much larger began to unfold, a phenomenon inseparably linked to a then young but rapidly expanding network. The Internet. It was the lifeline that allowed Linus Torvalds to share his creation across geographical boundaries, and thus trigger an avalanche of collaboration. Newsgroups, those digital bulletin boards of the early net era, particularly Comp.os, Minix, became the first gathering places for curious and enthusiastic developers. In parallel, email lists evolved into the pulsing arteries of the project, where ideas were exchanged, problems discussed, and early snippets of code were put into circulation. Without these open communication channels provided by the Internet, the rapid spread and development of Linux in this form would have been simply unthinkable. Every contribution, every question, every answer flowed through these digital streams and nourished the growing operating system. Linus Torvalds himself took on a role today known as Benevolent Dictator for Life, BDFL. This term may sound paradoxical at first, but it accurately describes his position. Linus made the final decisions regarding the heart of the system, the kernel, yet his leadership was far from an autocratic rule. Instead, from the beginning, he promoted an open culture of discussion in which arguments and technical superiority counted, not hierarchy. He delegated responsibility to trusted developers who maintained subsystems of the kernel and in turn submitted their contributions to Linus for final integration. This meritocratic approach, the acceptance of contributions based on their quality and relevance, regardless of the status of the contributor, was a cornerstone of its success. With each passing day, developers from all corners of the world began to contribute their expertise. They sent patches, small code changes, that fixed bugs, improved performance, or supported new hardware. Drivers for obscure components, innovative functions for the file system, or optimizations for special processor architectures found their way into the project. The modular structure of the kernel, sought after from the beginning, proved to be a blessing here. It enormously facilitated the integration of these numerous contributions, as changes could often be made in isolation within specific modules, without destabilizing the entire system. The choice of the new General Public License, GPL, for the Linux kernel was a groundbreaking decision that legally secured this open collaboration. It guaranteed everyone the freedom to use, study, modify, and pass on the code, thus creating fertile ground for unlimited innovation. But a mere kernel, as brilliant as it might be, was not sufficient for the end user alone. It lacked the tools, the graphical interfaces, and the applications that make up a complete operating system. Out of this necessity, so-called distributions quickly emerged. Companies and volunteer projects began to bundle the Linux kernel with a wealth of other software, often originating from the GNU project. Compilers, editors, shells. Later, desktop environments like KDE and GNOME were added, providing a user-friendly graphical interface. Names like Red Hat, Debian, or SUSE became pioneers of this movement. They transformed the raw kernel into complete, installable operating systems accessible even to non-programmers, thus opening the gates for broader acceptance. The once glowing lines on the stylized world map connecting individual developers now seemed to become denser and more complex. a web of countless hands and minds working together on a vision. A sense of silent but powerful harmony permeated the emerging digital realm, which grew steadily and spread quietly but unstoppably. Chapter 5: The Philosophy of Sharing, Open Source as Ideology. While the digital realm growing around the young Linux kernel continued to expand, a deeper question arose in Torvalds' heart, one regarding the fundamental principles that should guide the kernel's development. It was not technical brilliance alone that made this new world so attractive, but a philosophy of sharing that stretched like a fine invisible web over all involved. Often the term open source is equated with free of charge, a simplification that does not do justice to the true core of this movement. Understanding these ideas requires a precise distinction that goes beyond pure monetary value. It is not about free as in beer, meaning the gratuitous delivery of a product, but rather free as in speech, the freedom, anchored in the rights such software grants its users. This fundamental freedom encompasses four essential pillars: the unrestricted right to use the software as one pleases, to study its innermost essence, its source code in depth, to modify it according to one's own needs, and finally, to pass it on without restrictions. In this comprehensive definition, the actual power and deeper ethical claim of the open source ideology unfolds. It is an invitation to everyone to be not just a consumer, but an active co-creator. To secure these freedoms, not just as an ideal but as a tangible reality, a legal framework was needed. This is where the GNU General Public License, or GPL for short, entered the scene, a masterpiece of software ethics developed by Richard Stallman, one of the early pioneers of the free software movement. The GPL became the legal foundation on which numerous open-source projects, including the rapidly developing Linux kernel, were built. Its brilliance lies in the so-called copyleft principle. In contrast to traditional copyright, which protects the rights of the creator and restricts free distribution or modification, copyleft uses copyright in a reversed way. It not only secures the aforementioned freedoms of the users, but also ensures that all derivative works, meaning software based on and modified from a GPL-licensed program, must also be published under the same free conditions. This prevents someone from taking the free code, changing it, and then selling it as proprietary software with restricted rights. The GPL thus became the guarantor of continuous freedom and a true incarnation of the principle: what begins as free shall remain free. This licensing model has built a bridge between the right to intellectual property and the collective desire for unlimited access and cooperation. Another cornerstone underpinning the robustness of the open-source philosophy is the radical transparency and auditability of the source code. By making the complete code accessible to everyone, an unprecedented opportunity for quality control opens up. Experts and enthusiasts from all corners of the world can view, scour, and thoroughly test the code. This is far more than just a theoretical advantage. It is a practical mechanism that ensures bugs and potential security vulnerabilities do not remain hidden. Every additional pair of eyes analyzing the code increases the likelihood of identifying and fixing weaknesses before they can be exploited. This collective auditing process results in software that is not only of higher quality, but also more secure than many proprietary alternatives, whose inner workings remain hidden behind closed doors. Openness becomes a shield against hidden flaws and a promise of reliable functionality. Software ethics here place access to knowledge and technology in the foreground, viewing them almost as a fundamental right, which fundamentally distinguishes the social implications of proprietary and free software from one another. Chapter 6: Linux conquers the world, from servers to smartphones. From the flowing movement of the open-source philosophy we observed in the last moments, a concrete and all-encompassing presence arose that shapes the digital landscape of our time. Just as a deep-rooted tree grows in hiding yet cleans the air and provides shade, so has Linux, born of this spirit of collaboration, spread its roots into almost every corner of our technological world. It is a development that has turned the once modest creation from Helsinki into a silent giant whose influence is far greater than many perceive. One could call it the invisible backbone of the Internet. Let us observe the countless data streams rushing around the globe second by second, the countless requests sent and received by our devices. Almost all of these digital streams are directed through servers, whose internal mechanisms are powered by Linux. Its legendary stability, the ability to run for months and years without interruption, makes it the first choice for web servers that must handle billions of requests, for databases that store and manage vast amounts of information, and for the sprawling infrastructures of the cloud that form the basis of modern services. The inherent security, guaranteed by the continuous review and improvement of a global developer community, gives critical applications the necessary basis of trust, and its extraordinary adaptability, a direct consequence of its modular structure, allows Linux to be tailored exactly to the respective requirements, whether for a minimalist web server or a complex cloud platform. Thus, almost all large internet services, from search engines to social networks to streaming services, run on this robust foundation. Let us look further into the areas where pure computing power decides, into the awe-inspiring world of high-performance computing, also known as HPC. Here, the dominance of Linux is not only remarkable but almost absolute. Imagine the massive machines that perform our most complex scientific simulations, model the climate, or develop new drugs. Almost all of the world's fastest supercomputers use Linux as their operating system. This is due to the incomparable scalability of the operating system. The ability to work efficiently from a few processors to hundreds of thousands of computing cores, and its superior efficiency, the ability to manage resources optimally, and coordinate parallel processes with minimal overhead is of decisive importance in these environments. It is a technical elegance that enables these vast systems to push the boundaries of human knowledge. Then came the rise of smartphones, and with it another wave of Linux proliferation that few would have expected. When Google developed its mobile operating system Android, it consciously chose a modified Linux kernel as its foundation. This decision catapulted Linux into the hands of billions of people worldwide. Every time an Android smartphone or tablet is switched on, an app started, or a message sent, this Linux kernel works tirelessly in the background. A technical masterstroke that shows how a system originally conceived for servers and workstations could be adapted to meet the high demands for energy efficiency, responsiveness, and security in a mobile device. And so today we find Linux in an astonishing variety of embedded systems that permeate our daily lives. Often it remains hidden, a silent worker whose presence we rarely notice. From the smart TVs in our living rooms providing us access to digital content, to the routers connecting our homes to the internet, to the complex point-of-sale systems in stores and the highly developed infotainment systems in modern cars, Linux is at work everywhere. It is an invisible but omnipresent force. The adaptability of Linux is of crucial importance here, as it can be tailored to an immense variety of hardware architectures and specific functional requirements. Specially adapted Linux kernels even offer real-time capabilities, indispensable for the precise control of industrial systems and critical embedded applications where every millisecond counts. This ability to function efficiently on such a wide range of hardware configurations, from the smallest IoT devices to massive server farms, is what is known as the scalability of an operating system. The open source model driving the development of Linux has also created a robust business model, as proven by companies like Red Hat. They offer not only distributions, but also professional support and specialized services that make the use of Linux in business-critical environments possible and further consolidate the trustworthiness of the system. Thus, Linux, often unnoticed, shapes our entire digital everyday life in a way that is profound and fundamental. Chapter 7. Git, Torvalds' Second Revolution, a tool for himself. While Linux carved its silent paths through the digital landscape and established itself as the backbone of countless systems, the community of those working at its core also grew. With every line of code added and every function refined, an ever larger circle of talented developers from all corners of the world joined the project. This rapid expansion, as wonderful as it was for the innovative power of Linux, also brought a completely new kind of challenge. managing thousands of contributions, coordinating countless code changes, and securely merging these strands into a coherent overall code pushed the limits of the version control systems common at the time. It was like a massive river taking in more and more tributaries, its water level steadily rising, threatening the river to overflow its banks. For a few years, an external tool had been used to guide the floods, BitKeeper, a proprietary version control system. It fulfilled its purpose of taming the complexity of the Linux kernel development process. However, the dependence on a commercial solution that also restricted free use hung over the project like an unspoken promise. When this free use finally became unfeasible in 2005, the Linux community faced an acute dilemma: the need for an alternative, an open-source solution that could meet the specific requirements of such a dynamic and decentralized project, was more pressing than ever. It was a moment of decision, a fork on the long path of innovation. In this hour of need, driven by a very Linus-typical mixture of pragmatism and a healthy dose of frustration with existing options, Linus Torvalds himself took the initiative. Within a few weeks, in an almost unbelievable feat of creation, he developed a completely new version control system in 2005, Git. It was not primarily intended as a gift to the world, but rather as a tool he needed for himself and for Linux kernel development, a system that was to be fast, decentralized, and unrivaled in its efficiency. This was, after Linux itself, Torvalds' second great revolutionary invention, born of necessity and his inimitable ability to meet complex problems with radically simple but brilliant solutions. Git revolutionized the world of version control from the ground up. It was a prime example of a distributed version control system, DVCS, a concept fundamentally different from the previously dominant centralized systems like SVN. In centralized systems, constant access to a single server was required to save or retrieve changes. Git, on the other hand, functioned according to a completely different principle. Every developer had a full copy of the entire repository on their local machine. This meant that one could track, save, and merge changes even when offline. This opened up completely new dimensions of collaboration, especially for large, geographically distributed teams. The speed at which Git performed operations, be it cloning a repository, creating a branch, or merging code, was and remains to this day unmatched. It was a system designed from the ground up for the performance and flexibility of modern software development. A central element that made Git so powerful was its sophisticated merging algorithms. They made it possible to efficiently and safely merge complex code changes from different development branches. Where other systems often stumbled and required manual intervention, Git mastered this task with astonishing precision. Added to this was the use of cryptographic hashing algorithms, particularly SHA-1. Every change, every version of the code was given a unique hash that served as a digital fingerprint. This guaranteed not only the integrity of the entire code history, but also made manipulations or unintentional data loss almost impossible. Thus, Linus Torvalds created not only a tool that elegantly solved the problems of collaboration in large, distributed developer teams, but also laid the foundation for a new era of software development where flexibility, speed, and integrity go hand in hand. A system that, similar to Linux itself, arose from a personal necessity and developed into an indispensable global standard. Chapter 8: The Silent Giant. Torvalds, Gates, and Jobs in comparison. The history of technology is rich in defining personalities whose names are inseparably linked to the innovations they pushed forward. When one looks at the milestones of the computer revolution, three central figures usually emerge whose influence on the digital world is undeniable, yet whose public perception could hardly be more different. There is, on the one hand, Steve Jobs, the charismatic visionary from Cupertino whose name became almost synonymous with design, aesthetics, and a revolutionary user experience. Then Bill Gates steps into the spotlight, the business-savvy pioneer from Seattle who domesticated the operating system for the masses and created a global software empire. And finally, Linus Torvalds, the introverted Finn from Helsinki whose creation, though ubiquitous, operates in the background, often overlooked by the public. Three men, Three very different paths to global influence. Steve Jobs was undoubtedly a master of self-promotion. His appearances on stage resembled carefully choreographed theatrical performances that elevated products to works of art and technology to an emotional experience. With his iconic black turtleneck and the dramatic "one more thing" at the end of his presentations, he didn't just sell devices, but an entire philosophy, a lifestyle characterized by innovation and rebellion. The fascination surrounding his person was so great that Hollywood made 2 films about his life, and Walter Isaacson's comprehensive biography became a global bestseller. Jobs' notorious reality distortion field, the ability to convince those around him of seemingly impossible ideas and push the boundaries of the feasible, has long since entered common parlance. Despite his genius, Jobs also had dark sides that were not omitted in his biographies. The years of denial of his daughter Lisa, his uncompromising hardness, and sometimes brutality toward employees. Yet the myths surrounding him outshone these shadows, consolidating his image as a brilliant outsider who changed the world. Bill Gates, who for years held the title of the world's richest person, undisputed, experienced a transformation of his public persona that was as remarkable as it was radical. In the 1990s, he was for many the epitome of the evil monopolist, an image cemented by the long-running U.S. antitrust lawsuit against Microsoft that kept the entire tech world in suspense. But then he carried out one of the most spectacular image changes in economic history. Together with his then-wife Melinda, he founded the Gates Foundation, a philanthropic organization that has invested over $100 billion in global health programs. The renowned journalist Malcolm Gladwell once speculated that in 50 years, statues might be erected for Gates, not for Jobs. This narrative of the capitalist's redemption is, however, not without controversy. Critics express concerns about whether a single private individual with such gigantic donation sums does not de facto exercise a kind of informal power over global health policies, especially since the Gates Foundation is today one of the largest private donors to the World Health Organization, WHO. Journalists and system critics question the ethical dimension of vaccination programs in poorer countries that are pushed forward without sufficient democratic control or local participation. The question of whether genuine compassion, a quest for control, or the search for immortality motivates these actions remains complex and multifaceted. One thing is certain: philanthropy on this scale is never free of the exercise of power, and power is rarely free of self-interest. Linus Torvalds, on the other hand, embodies a completely different kind of influence. He has created something used daily by more than 4 billion people worldwide, and yet he remains largely unknown outside the tech bubble. There is no Hollywood film about his life, no glamorous appearances on talk shows, no carefully curated Instagram profile. Torvalds lives a middle-class life in Oregon, drives an inconspicuous car, and receives a good but by no means astronomical salary from the Linux Foundation. The cause of this blatant discrepancy between his global influence and his public fame lies in the nature of his creation. Linux is invisible. It is the silent infrastructure acting in the background of the digital world, comparable to water from the tap or electricity from the socket. One does not notice it as long as it works smoothly. With over 70% market share in smartphones, Android is based on Linux, 96% of web servers, and even 100% of all supercomputers worldwide since 2017, as well as around 49% of cloud workloads. Torvalds' work is the foundation of countless digital processes. His fortune is estimated at $50 to $250 million US, which compared to Gates' $107 to $162 billion US, or Jobs' $7 billion US at the time of his death in 2011, represents a completely different order of magnitude. This difference in scale clearly shows why open-source developers rarely become billionaires. Their work is often provided freely and shared. The decisive question that arises here is thus: fame or impact? Nathan Covey summarized it aptly in 2024. Many argue he is as influential as Steve Jobs or Bill Gates, but he is much less known. The business magazine Sway.Null even wrote provocatively in 2006 that Torvalds was among the 10 people who were no longer important, not because his work had become meaningless, but precisely because Linux has become so monumental and ubiquitous that it has long since surpassed its individual creator, this invisibility as success is perhaps the greatest compliment one can pay a visionary, for it testifies to how deeply his work has penetrated the foundation of our modern world. While Jobs staged himself as a product, and Gates bought a form of immortality through philanthropy, Torvalds gave his work to the world, and exactly through that he became the silent, indispensable infrastructure builder whose influence is subtle yet fundamental. Jobs and Gates are brands, symbols of capitalism and consumption. Torvalds is the foundation, the silent, often overlooked basis on which a large part of our networked existence rests. Both types of influence exist side by side, but only one invisibly permeates every corner of digital life. Chapter 9 Linus Today, AI, Rust, and a Succession Plan. While the digital universe Linus Torvalds once shaped with his own hands continues to expand and move into ever-new spheres, its creator still sits at his keyboard. For over 3 decades he has dedicated himself to the maintenance and development of that kernel he brought to life as a mere 21-year-old student. But the world around him, the technological landscape in which he has his firm place, has changed dramatically. Artificial intelligence, once a domain of science fiction, is now on everyone's lips, and new programming languages are vying for attention. Inevitably, the quiet but persistent question arises, who will carry on this colossal legacy after Linus? When the wave of AI enthusiasm reached its glowing peak in 2023 and 2024, Torvalds showed his own unshakable mixture of sober pragmatism and a healthy dose of skepticism. He commented on this phenomenon with characteristic directness. I think AI is really interesting, and I think it will change the world. And at the same time, I hate the hype cycle so much that I really don't want to go there. His assessment of large language models was concise and revealing. He called them autocorrect on steroids, a highly developed form of pattern recognition that, however, represents no real deep thinking in the human sense. But by the spring of 2026, his perspective had shifted, albeit only slightly. The idea that AI-supported programming, as offered by tools like GitHub Copilot or Cursor, could, if used cautiously and consciously, further drive the democratization of code, a goal he has championed his entire life. This development, he recognized, holds the potential to create efficiency even in complex kernel development, without undermining human control or critical thinking. Another profound debate that has occupied the Linux community for some time is the integration of Rust, a modern programming language, known for its extraordinary memory safety, into the Linux kernel. For decades, the kernel has been written, almost reverently, in the language C. Torvalds fundamentally supports the introduction of Rust but speaks openly about the challenges that arise. I had expected that progress would be faster, he noted. But the problem is that old kernel developers are used to C and don't know Rust. The fundamental advantage of Rust, memory safety, is a central argument for its introduction. As many of the historical security vulnerabilities in the Linux kernel that led to serious problems could have been avoided from the outset with Rust, when the discourse escalated in 2025, and a maintainer made the unfounded claim that Torvalds was integrating Rust code into the kernel against his own will, Linus responded with his own concise and unmistakable clarity. Maybe the problem is with you, he meant unmistakably. It wasn't him who had a problem with Rust, but the maintainer with his own rejection of the new. It was his way of saying, don't pin your resistances on me. This generational conflict between C veterans and Rust enthusiasts shows in a poignant way that even in the largest and most successful open-source project in the world, human tensions and differing views are an inherent part of the development dynamic. In February 2026, Torvalds surprised the tech world with a humorous yet symbolic announcement. The next kernel version, he explained, would not be called 6.20 as expected, but would bear the remarkable name 7.0. His reasoning, which he published on the official mailing list, was typical of his self-deprecating style. I confuse myself with big numbers. I'm almost running out of fingers and toes. It was a classic Torvalds moment, perfectly combining his pragmatic approach and dry humor. For the entire tech world, however, this seemingly simple numerical change was far more than just a whim. it was interpreted as a symbolic milestone that could herald a new era of the kernel, and gave cause for reflection on the conventions of version numbers in the open-source world, where large jumps often signal deeper structural changes or a new direction. In January 2026, something happened that many in the Linux community had considered unthinkable for decades. A formal succession plan for the leadership of the Linux project was adopted. This historic document, which Torvalds personally signed, was the result of a kernel summit in Tokyo, where the assembled developers spoke openly about the inevitable movement toward our deaths, an honest confrontation with finitude, and the necessity of securing the project for the future. The name most frequently mentioned as the most likely successor is Greg Kroah-Hartman, an extremely experienced kernel maintainer whom Torvalds has trusted deeply for decades. The exact structure of the future leadership, whether it will be an individual or a collective leadership council, remains open for now. Linus himself commented on this forward-looking development with his usual dry humor. He is pondering his succession, a statement that expresses both his involvement and his detached composure in this significant matter, and for the first time institutionally forces the Linux community to think about the time after Linus Torvalds. Chapter 10: The Legacy of a Penguin, the Influence and the Person Linus Torvalds. While the mental paths of succession fade into the distance of a still uncertain future, the gaze turns back to the origin, to that central figure who created this impressive ecosystem and shaped it over decades. Linus Torvalds himself, the human being behind the myth, is a personality whose traits are often described as unpolished, sometimes even abrasive. Linus Torvalds is known for a way of communicating that he considers necessary to ensure the extremely high technical standards and uncompromising code quality of the Linux kernel. He does not shy away from addressing errors directly and conducting technical discussions with a clarity that leaves little room for misunderstanding. Behind this pragmatic and often blunt facade, however, is a deeply skilled engineer who has dedicated himself entirely to code, functionality, and efficiency. His apparent sternness is in truth a manifestation of his unwavering dedication to the technical integrity of the project. Even after decades of unparalleled leadership, Linus Torvalds remains the undisputed central figure in the development of the Linux kernel, the so-called benevolent dictator for life. This designation is far more than a mere title. It describes a unique role in the open-source universe that is crucial for the continuity and stability of the project. In a project management context involving the coordination of thousands of globally distributed developers, the challenges are immense. The strategies for managing this complexity, from setting clear technical guidelines to moderating profound architectural decisions, lie largely in Torvalds' hands. His ability to guide technical discussions precisely, integrate different viewpoints, and ultimately find a consensus, even in heated debates, is an art in itself and indispensable for the smooth further development of the kernel. He manages to channel the creative energies of a massive community without losing the coherence or technical vision of the project. The influence that Linux and the version control system Git developed by Torvalds have exerted on the entire software development industry can hardly be overestimated. They have fundamentally changed the way software is conceived, developed, and maintained. The open-source model, which Linux so successfully exemplified, is today an established standard in the industry and far beyond. It has massively accelerated technological evolution through openness by making innovations freely accessible and democratizing access to technology. Without Linux, today's cloud infrastructure, the dominance of Android in the mobile market, or the multitude of specialized embedded systems in our daily lives would not exist in this form. Likewise, efficient version control as provided by Git is indispensable for any modern software project. It enables collaborative work at a level that was previously unthinkable and forms the backbone of almost every major development. The legacy of Linus Torvalds is thus far more than just an operating system kernel or a version control system. It is a deeply rooted philosophy of cooperation, freedom, and constant improvement. It is a living heritage that is being continued daily by millions of people worldwide. The social dynamics in the Linux community, unfolding in forums, email lists, and at global conferences, are an exemplary model for knowledge exchange and collective decision-making in a decentralized environment. These open communication channels form the nervous system of the project through which new ideas flow, problems are solved, and the future of the kernel is shaped together. In this steady flow of contributions and interactions, the Penguin legacy is revived, further developed, and adapted to the challenges of a constantly changing digital world day after day. Outro. Over the last few hours, we have taken a quiet journey that led us deep into the thoughts of a young Finnish student. A journey that began with his first curious steps on the Commodore VIC-20 and evolved into a global movement. His unwavering curiosity and a deeply rooted pragmatism formed a legacy that changed the digital world from the ground up, from the foundations of the Linux kernel to the elegant efficiency of Git, which coordinates the collaboration of millions of developers worldwide. Linus Torvalds has impressively shown us that the most significant revolutions often do not arise through thundering declarations or spectacular gestures. Rather, it is the quiet, persistent hours of work, the meticulous attention to detail, and the absolute belief in the power of open collaboration that bring about true transformation. His work is a glowing monument to the profound power of sharing, of knowledge, code, and ideas, and to the inherent beauty that lies in a system that continues to grow and thrive through collective effort. And perhaps we should pause for a moment and be grateful that this powerful engine of the digital world was never subjected to the dictates of profit. No shareholder determines where Linux develops. No license fee locks knowledge behind closed doors. This principle of openness is no coincidence but a conscious decision, and it has driven technological progress at a pace that no single company, no closed laboratory could ever have achieved. When millions of minds work together freely, something arises that far exceeds the sum of its parts. Thank you, Linus Torvalds. Now that this narrative about Linus Torvalds is approaching its harmonious conclusion, I invite you to let your thoughts drift like soft clouds in the night sky. Imagine how this tireless code, which he once brought to life and which countless helpers have refined over the years, performs its work steadily and inconspicuously in the background of our complex digital life. Let this peaceful certainty accompany you now into a deep, beneficial, and truly restorative sleep. May you come to rest this night and dream of the almost limitless possibilities that open architectures and the communal spirit offer us all. May these dreams tell of new horizons that we can discover together. And if you are fascinated by how rapid this progress really is, in another video we ask ourselves together, what actually happened in the last second? Good night. That was today's night lesson. Thank you for listening. If you'd like to see more videos like this, please leave a like and subscribe to the channel. Good night and sleep well.